Hello students, welcome to our today lecture. In our today lecture, we want to see that under what conditions we can apply VAR model. So basically there are two methods which are being used for the checking of long run relationship between the variables. One is VAR and the other one is VECM, Vector Error Correction Model, and other one is VAR, Vector Autoregression. So basically, first of all, we have to apply Johansen co-integration test, and if there exists a long run relationship, if there is co-integration between the variables, then we apply VECM model, and if there is no co-integration between the variables, then we will apply VAR model. So that is our objective for today lecture. So first of all, we have to bring all of our data set into STATA file. So for that, go to Excel file, copy your all data from Excel file, then go to STATA, go to data editor and paste all your data here, and then go with this option, treat first row as variable name, then go back to main file, then go to statistics, then go to multivariate time series analysis, then go to co-integrating rank of VECM. So after applying this, we will come to know that either there is a co-integration between the variables or not. So let's do this, and here you have to select your dependent and dependent variable. So let's say I am going to take only two dependent variable out of these four variables. One is POPD and the other one is GDP. Then go to reporting, then select this one, report maximum eigenvalues. So basically there are two methods to check that either there exists a co-integration or not between the variables. One is trace test or trace stat, and the other one is max eigenvalues. So we are going to present the result of both of these. Then go to time setting. In option from time variable, select year as your time variable. Then from these options, select the nature of your data set. As my data set is yearly, so I am going with this option of yearly. Then click on OK, and here you have to select the number of lags. And in our previous lecture we have already discussed that what is the maximum lag, that how can we select maximum lag through different methods, a lag through lag selection criteria. So let's say that lag selection criteria tell us that include 5 lags in your model. So I want to include 5 lags in my model, then click on OK, and here it has given us the results for Johansen test of co-integration. Above table is showing the result for trace statistics, and the below table is showing the results for max eigenvalues. So we can interpret or we can check that either there is co-integration between the variables or not from both of these two methods. So what is H naught? H naught is there is no co-integration or there is no co-integrated equation, and alternative hypothesis that there is co-integration. So what is the guideline that how can we reject or accept this H naught? We have to compare this trace stat value with the 5% critical value. If the trace stat value is less than critical value, then we have to accept the null hypothesis. Let me repeat it again for you, that if trace stat, this value, is less than the critical value, then we have to accept the null hypothesis, otherwise we reject. If this value is greater than critical value, then we will reject the null hypothesis and accept the alternative hypothesis. But in our these results, we can see that trace stat value is less than critical value. The trace stat value is 12.4 and critical value is 15.4. So we can accept the null hypothesis. By accepting the null hypothesis, we can conclude that there is no co-integration between these variables. So when there is no co-integration between the variables, in that case we can apply VAR model. And if there exists co-integration between the variables, so we have to apply VECM. But in our case, we have to apply VAR model as there is no co-integration between the variables. Now look at max eigenvalues, what they are telling us. If you look at max eigenvalues, max statistic value is 9.88 and critical value is 14.07. So it means that this value lies well below than this. So it means that we have to accept a null hypothesis. So both of these two tests tells us that there is no co-integrated equation in this model. So we are good to go to apply VAR model. Let me write all of these things here. As our traced stat value is less than critical value, so we have to accept the null hypothesis, which means that there is no co-integration and we can apply VAR. So this is all for our today lecture, and in our next lecture we will apply VAR model and we will see that how to interpret the results of VAR model.